this is example 1 of lesson 2.7, the distributive property with variables. But before I get into the variables, I want to make sure that we know what distributive property is. Say I'm trying to multiply 12 times 22. Let's go ahead and move these up here. This time do 12 times 22. Now, I'm going to rewrite this in a way that I can do it in my head, because I don't know my 22s off the top of my head, and I don't know my 12s to 22. So, I'm going to rewrite this as 12 times, using the parentheses, 20 plus 2. Now, you're looking at this saying, order of operations, that I have to do it in the parentheses first. Well, that would get me back to 12 times 22, and that's not what I want. I want 12 times 20 plus 12 times 2. And I can rewrite this as 12, as I just said, times 20 plus 12 times 2. And that's what the distributive property is. I can take things apart, and this 12 here gets applied to the 20 and the 2. The 12 applies to everything in the parentheses. Now I can do 12 times 20, which I know is 240, because 12 times 2 is 24 out of 0, plus, oh, here's 12 times 2 again, 24, equals 264, which is a lot more straightforward, and I can do this in my head better than I can do 22 times 12, like that. I can do this a lot faster. So that's the distributive property in a nutshell there. What's the super short version? Basically, it says you can break apart numbers and multiply them separately as long as you multiply all the parts. We're going to use the distributive property a slightly different way here. We're still going to be distributing our numbers, but we're going to be doing it with variables. Now, looking at this, you see 2 times x plus 6. And you're going to want to say you have to do what's in the parentheses first. And while that's true most of the time, there really isn't anything we can do here. We don't know what x is. We don't need to know what x is. X doesn't matter right now. It doesn't matter what x is right now. We just know that we cannot add it to 6. And no, 6 plus x is not equal to 6x. That would be x times 6, not x plus 6. So what are we going to do to simplify this? Well, we're going to distribute the 2. The 2 is being multiplied by both the x and the 6 here. Or the 2 is multiplying the x and the 6 here. So what we're going to do is rewrite this. 2 times x plus 6 is the same as 2 times x plus 2 times 6. And now we can simplify this. 2 times x is 2x plus 2 times 6 is 12. Now this here expression and this here expression are what are called equivalent expressions. They are the same. If I plugged in 3 for x, I would get the same answer in both of these expressions. Important thing to note. This here is as far as I can go. I can't go any farther. This is my answer. If I ask to distribute this, this is what I'm going to get. Nothing farther than this. It's not going to be 14x or 24x or whatever. 2x plus 12. Let's do another. Just like we did previously, we're going to distribute the 5 to the y and to the 8. So we're going to rewrite it 5 times y minus, because we have a minus sign here, minus 5 times 8. 5 times y is 5y, minus 5 times 8 is 40. And my answer is 40. That is my final answer. This expression and this expression are equivalent. They are the same. And this is my final answer. One more here. 4 times 3x minus 2. I can't do anything in the parentheses. There's nothing to do, so I'm going to distribute the 4. The 4 applies to the 3x and to the 2. So 4 times 3x is what we have, minus, because the sign stays the same, 4 times 2. 4 times 3x is 12x. Again, here, just like when we were combining like terms, when we're multiplying constants by coefficients, we just multiply the coefficient, and the exponent stays, not the exponent, the variable stays the same. Minus, and 2 times 4 is 8. And that, there, is my final answer. I'm not solving any farther than this. 12x plus 8 is the same, is equivalent to 4 times 3x minus 2. And that is the distributive property with variables.